Imagine you walk outside one morning and find a perfectly straight, smooth tunnel drilled straight through the entire Earth, from one side of the planet to the other, passing directly through the core. It's reinforced, magically heat-proof, pressure-proof, and, for some reason, completely evacuated of air. A perfect vacuum. No molten rock dripping from the ceiling. No crushing pressure. Just a clean, silent, impossible tunnel. And because you're a reasonable human being, your first thought is, of course, what happens if I jump in? At first, nothing much. You push off from the edge and begin falling slowly. Gravity starts pulling you toward the center of the Earth, and with no air resistance to slow you down, you accelerate faster and faster. Within a minute, you're falling at speeds that would make skydivers jealous. After 5 minutes, you're moving faster than a jet. Eventually, faster than a bullet. All the while, the walls blur around you as gravity pulls you toward the core with increasing intensity. But something strange starts to happen as you approach the center. Gravity pulls you inward from all directions equally, and those forces cancel out. That means that right at the very center of the Earth, you suddenly become weightless, completely weightless. Not because gravity disappears, but because it pulls you equally from every direction at once. If you stopped there and just hovered, you'd float forever like an astronaut in a zero-gravity chamber. But you're not stopping. You're still moving at incredible speed, and momentum carries you right past the center. As you fly through the exact middle of the planet, you begin slowing down. The same gravity that pulled you toward the core is now pulling you back toward it, trying to drag you back to the center. Every second you climb upward through the tunnel, you lose more and more speed, trading kinetic energy for gravitational potential energy. Eventually, after about 42 minutes of non-stop motion, you finally slow to a stop, exactly at the surface on the other side of the Earth. You pop out of the tunnel as gently as you jumped in, like a human-sized elevator powered entirely by physics. If you did nothing at this point, gravity would immediately pull you back down the tunnel again. You'd fall all the way back through the core and pop out where you started, then fall again, and again, and again, like an enormous planet-sized pendulum. You'd oscillate back and forth forever unless friction or a stray gust of air ruined the perfect system. But what if the tunnel wasn't a vacuum? Suppose it contained normal air. The fall would become a nightmare of friction and heat. You'd hit terminal velocity, slow down, heat up, and at some point simply stop somewhere halfway to the center. You'd be stuck in a deep, dark tunnel with no way to climb out. Not the ideal outcome. There's more. The Earth rotates, and you, standing still at the entrance to the tunnel, rotate with it. As you fall inward, however, different layers of the Earth rotate at different speeds. Near the equator, you're moving over 1,000 kilometers per hour. Near the core, the tangential speed is much smaller. Without magical anti-Coriolis stabilizers, you'd slam into the tunnel wall at hypersonic speed almost immediately after falling in. The tunnel would need constant active correction to keep you centered as the planet spins beneath you. But assuming all the magic and engineering problems are solved, no heat, no pressure, no air, no rotation, you'd have the most spectacular ride in human history. A 42-minute fall through an entire planet, a moment of perfect weightlessness at the core, and then a gentle arrival on the opposite side of the Earth. It would be the most extreme roller coaster ever built, powered entirely by gravity and the impossible idea of drilling through a molten iron ball the size of a small starship. And after you pop out on the far side, there's only one question left. Do you jump in again?